here we go. This right here, we have the integral of e to the inverse cosine x. I'm actually going to just take a u sub first, right? So let's go ahead and do that right here. I will let u equal to inverse cosine x. And then I will take the original on both sides. So this is the same as saying x is equal to cosine of u. From here, we can just differentiate both sides. We can see that dx is just equal to negative sine u du. And you guys know it. We'll take this integral to the u world. And you'll see this is going to be really, really nice. This right here is equal to the integral, and we have e. And then this right here is just going to be our u. And then dx is equal to all that, which is we have the negative sine u du, like this, right? So that's really good. Now, I'm just going to clean things up a little bit. And I'm actually just going to put a negative in the front. Here we have negative integral, and we have e to the u sine u du. As you can see, after the u substitution, even though originally the integration right here looks pretty scary, but once we are in the u world, this is actually one of the integrals that we have done in class, right? And this is actually a repeating situation, but I want to give a special shout out to Professor Michael Penn, because he showed us a really nice method that you do not have to write this down as an equation and like add it to the other side and things like that. So if you don't know what I'm talking about, let me demonstrate. So let me just, again, thanks to Professor Penn. Right? And if you guys don't know who he is, you guys should definitely check out his channel. So Professor Michael Penn, right? So this is what I learned from him. First off, I'm actually going to look at this right here, and you see, we want to do integration by parts. You can differentiate e to the u, and you can integrate e to the u. Likewise, you can also differentiate and also integrate sine u. They're both pretty easy, right? In that situation, I'm actually going to have two copies of this. But originally, we have -1, so this is what we have to do. First, we're actually going to write this down twice. So we have the integral of e to the u sine u du, and then I'm going to add it with the integral of e to the u sine u du. So I have two copies, right? But I have only -1 right here. So what we have to do is just multiply the whole thing by -1/2. So are we okay so far? This plus that is two integrals, and then multiplied by the -1/2. We still have the original. Now check this out. For this integral right here, I'm actually going to do the integration by parts right here, of course, the DI method, and we'll just need two rows. For this one, I will actually differentiate e to the u and integrate sine u, and you will see this is just e to the u, and this right here is going to give us negative cosine u. But for this one, I will actually differentiate and integrate the other ones. So I will actually differentiate sine u right here and then integrate e to the u. Well, differentiating sine u, we get cosine u. Integrating e to the u, we still get e to the u. So that's really nice. Now, have a look. All the way in the front, we still have the -1/2, and then me actually put this down right here. I need to make sure I have enough space for everything. For this integral, I will put down all this in red. Well, when we multiply the diagonal, we know that's the first part of the answer, so we get this times that, which is negative e to the u cosine u. And then don't forget that when we multiply by this row, this is still going to give us an integral, right? Negative times negative, we have the plus integral, and this is e to the u cosine u du, like that. Well, we are done for that, which is really good. Now we do the second one. For this one, again, this times this, that's going to give us the first part of the answer, and that's going to be plus. So plus e to the u. This is going to give us sine u right here. And then when we multiply by this row, as you can see, we have a negative, right? And then this is integral, and let's put down e to the u first. And then we have cosine u du. And do you guys see it? Inside here, this and that are the same but opposite sign. So of course we can just cancel them out, which is very, very nice. So if you notice that it doesn't really matter which part to be differentiated or which part to be integrated, give this kind of technique a try. So that way you don't have to write an integral equation and then add it to both sides. You don't have to do it like that. Really cool. Well, in the end, I'm just going to multiply the negative 1/2 inside, and then I will actually put a u back, and that's pretty much it. So let's see what we will end up with at the very end. Yeah. So finally, this is the answer. 1/2, right? And then this right here is x. And then this right here is just e to the cosine, and the inverse, and x. So that's the first part. And then for the next part, we multiply this and that, so we get negative, and then we have 1/2. And well, what is sine u though? We know x is equal to cosine u. So what is actually sine u? Of course, what you can do is just plugging this right here into the u here, but that will be pretty intimidating. That's not that great. So let's do some work right here. If you look at this right here, cosine u is equal to x, which is the same as saying x over 1. Yes, I like to draw the special right triangle, so let's go ahead and draw the right triangle. So right here, you can see that this is going to give us, well, cosine is x right here, adjacent over hypotenuse, which is 1. And then the angle is the u. And to figure out the hypotenuse, this right here is just equal to, you open the square root, and you do the hypotenuse square minus the other side square. Yeah, just like that. So as you can see, by looking at this triangle, sine u is just opposite over hypotenuse, which is just that, right? So I will put that down first. Then the square root of 1 minus x squared. And as a friendly reminder, 1 squared is equal to 1. I didn't forget to put down the 2. Anyway, yeah. Anyway, last part, we have e to the u, which is e to the cosine inverse of x. And we are all done. And you guys know the deal. Plus c somewhere. Just put it down. I like to write everything on the same line whenever possible. So, ladies and gentlemen, this right here is the first one. You might want to do a u sub first, but I tried it. That's actually slightly longer. It's actually easier if we just go ahead and do integration by parts. Remember, for integration by parts, we are trying to integrate just one part of the integral and then differentiate the other part. But technically here we just have one part right here, right? So we really have no choice. We actually just have to try to differentiate this instead. And let's see what will happen. Now that's pretty much the style. If you don't know how to integrate this, maybe try to differentiate that. But now you might be wondering, how about the other part? Yeah, we can just put down a 1. Yep. So even though you only see 1, but actually you can even though you only see one function right here, but you can always try to integrate 1, which is technically the dx right here. All right, let's do the easy part first. Integrating 1. Everybody happy. Okay, differentiating inverse tangent of square root of x. Well, we get 1 over 1 plus this thing inside here, and you square that. So we have square root of x and you square that. And of course, don't forget the chain rule. Multiply by the derivative of the inside. The derivative of square root of x is 1 over 2 square root of x, like that, right? And now let's just see what will happen after this. I cannot guarantee that this will work every single time, but it's just going to be a good try. All right, so ladies and gentlemen, we have the first part of the answer. This right here is equal to x times the inverse tangent of square root of x, which is pretty nice. Now, don't forget, when we multiply by this row, this is still going to be an integral. So let's see what will happen. Can we really integrate this? This is going to be a negative integral. We'll put this on the top, and then put down the 2 right here first, and then we have the square root of x, and then we have that, which is actually just 1 plus x, like that, yep. Well, you can actually simplify this whichever way that you would like. You can look at this as x to the first power divided by x to the 1/2 power. 1 minus 1/2, you get positive 1/2. So in fact, this is just going to be simplified into square root of x on the top. So that's pretty much what we have. And in fact, this is actually doable. Let's use the blue pen for the first time today. Let's do it on the side, just for this part. Here, let's see, what's the integral of? We have the square root of x over 1 plus x. And perhaps Should I put on a 2? I think let's just put on a 2 as well. Let's see what will really happen, right? So let me include a 2. All right, so right here, let's do a U substitution right here and hope for the best, I will say. Take U to be square root of x. Take U to be square root of x. I shouldn't say it's pretty natural, but just give it a try, right? Well, right here, we need to get dx. It's actually a good idea to square both sides first because you can isolate x pretty easily and then differentiate this. You get dx being equal to 2u du. So that's actually the straightforward method to get the dx in this case. Well, this right here gives us 1/2 integral. This guy is the u over 1 plus x is the same as u squared. Dx is equal to 2u du. Hey, it's actually really good that I brought the 2 on the bottom with us because the 2 on the bottom can be cancelled out with this 2 right here, right? So that's pretty good. And then in fact, this becomes the integral, and then we have u, which is u squared over 1 plus u squared du. And now, how can we do this? U squared over 1 plus u squared. This is actually my favorite approach. I like to ask myself, wouldn't it be nice? Right? You ask your question by starting with the phrase, wouldn't it be nice? Look at this and you ask yourself, wouldn't it be nice? Well, what? Wouldn't it be nice if we actually have 1 plus u squared on the top instead? Yes, because that case, the whole thing is just going to be 1, which is very nice. So let's go ahead and just put a 1 plus right here, but of course I cannot just do that. Otherwise I change the whole thing. It's actually not so bad because we can just minus 1 and pretty much pretend nothing happened. But you can see that this is so nice because this part, 1 plus u squared over 1 plus u squared is just 1. And then if you allow, you can close the integral, but let's put everything inside. We have then minus 1 over 1 plus u squared. And keep in mind, we are in the u world. Because when you integrate 1 in the u world, you will have to put down u. Yes, u. U. And then minus inverse tangent, that's the integral of that. And then here we have the u right here. So that's pretty much all. And then of course, in the end, we just have to plug in the square root for the u, square root of x. So finally, this is what we have. And you know what? I'm not going to put on the plus c right here. Why? Because this is just like an appetizer. This is the main dish. So ladies and gentlemen, right here, I'm going to write down x times the inverse tangent of square root of x minus, I'm actually going to distribute the minus right here, so check this out, minus times that, which is minus square root of x, right? So again, let me just emphasize we are distributing the negative right here, and then minus minus, we get a plus right here, and then we have the tangent, and this is the inverse, and then we have the square root of x. Man, again, I'm about to run out of space for the plus c, but of course, you have to always put on the plus c. So finally, this right here is the answer. So this right here is not so bad. It's like a combination of integration by part question and also maybe not so clear trig, no, not trig sub, I mean u sub question. So let's just jump right into it for the integration by parts. Right here, pick one part to be differentiated, pick another part to be integrated, plus minus on the side just to get ready. It's always harder to do integration. If you look at this part right here, it's impossible. But just think about it. Which part can we actually integrate? If you look at sine of 1 over x, we have an inside function 1 over x. And remember, when we differentiate 1 over x, this gives us negative 1 over x to the second power. You see here we have x to the third power on the bottom. We have an extra x, right? Just push it to the part to be differentiated. So actually, let's look at integrating sine of 1 over x squared. And then we still have to have the 1 over x right here, right? So if you take a look right here, and if you multiply this and that, yes, we still end up with the original, right? And now let's try. So this is what I mean by you should always try to pick the part to be integrated. Whenever you can, just go ahead and give it a try and differentiate the other part and hope for the best. Let's do that first to make us feel better. Differentiating 1 over x is negative 1 over x squared. How do we know? I put it down right here for you guys already, right? Now, do a u substitution, let u equal to this. And you'll see that the x squared and x squared will cancel, but we end up with negative. Integrating sign, we get negative cosine, right? Negative cosine times negative 1 right here, it becomes positive. So we have positive, and then we have the input, which is just 1 over x. You can go ahead and just put this down and then differentiate this real quick in your head. Differentiating this, we get negative cosine. Well, differentiating this, we get negative sine. And then multiply by this, and you end up with that, right? So that's pretty good. Now you guys know the deal. Multiply this and that. That's the first part of the answer. And for, let's still write this down. I like to put it down in this kind of order. So I'm going to just write it as 1 over x times cosine of 1 over x. Right, that's the first part of the answer. Then you multiply by this row, and this is going to be negative negative, which is going to be plus. So I will add on plus integral, and then we just have the 1 over x squared times cosine x, cosine of 1 over x. Like that, right? Which is pretty good. And how do we do this? Yes, we do u sub again. Let u equal to 1 over x, right? So we're pretty much done. So I will write down the answer for you guys. All right, so here we have 1 over x, cosine of 1 over x. Integrating cosine, we get positive sine. And then the input stays the same. All right, plus or minus right here. You guys do it. Minus. Why minus? Because when you're differentiating sine, you get cosine, and the input stays the same. But use the chain rule, multiply by the derivative of this, which is negative 1 over x squared. Negative times negative will give you the plus, right? So it's negative. So, ladies and gentlemen, this right here is it, plus c. So, this is number 3, right? So, that's it. You know it will be integration by parts somewhere, because that's the topic today. But which part shall we pick to be integrated and which part shall we pick to be differentiated? Let me try this first, yeah? So if I'm doing this for the very first time, or I should say if you guys are doing this for the very first time as well, try this. We have 3 parts, 3 functions to choose from, right? Well, actually 4 because you have the 1. So let's see. Do I want to just integrate x? Well, if I do that, then I have no choice but to differentiate inverse sine x over that. And this is going to be pretty horrible, right? When you differentiate this, you have to use the quotient rule. Yes, you have a really good time right here, but you know, no. Sometimes you have to work hard for this. So this is the no right here. Right? So don't do it like this. So now let's see, what if we do inverse sine x over square root of 1 minus x squared? Can we integrate this? The answer to that is actually yes, because the derivative of inverse sine is precisely 1 over square root of 1 minus x squared. So this is actually doable. Well, in that case, we will just have to put down the x right here for the differentiation. And let me give this a try and see how it looks. Differentiating x, we get 1. Integrating this, pick u to be inverse sine, and then it's just going to be integrating u in the u world. So you actually just get 1/2 u squared, which is just going to be inverse sine x raised to the second power. And if you guys have seen my video, thank you so much. When you have this kind of situation, please don't ever write this kind of notation. This is perhaps the worst notation ever. Don't ever do it like this. This means the inverse sine x and then raised to a second power. All right, so we achieved this, right? Not so bad. Okay, this times this, it's the first part of the answer, sure. But when we multiply this row, we will have to integrate 1/2 inverse sine x and then to the second power. I don't think that's enjoyable. Even though it's doable though, you just have to do integration by parts a few more times, but it's not enjoyable. So I'm actually going to stop right here. Right? This is actually not what we would like. I leave this on the board just to show you that that's one of the things that we have tried. Now, let's use the blue pen and see what happens. Blue pen is here to rescue us. Well, that's a good idea, but we just have to maybe change it. The truth is, instead of putting down inverse sine x over square root right here, let's do x over that. That is still something that we can do. So let's integrate x over square root of 1 minus x squared. That's actually something that we can do. And then let's differentiate inverse sine x, all right? And yes, if you guys have seen the usual technique, the Liati, so Li, A, T, E, like this method, which stands for you should differentiate logarithm function, inverse functions, algebraic functions, trig functions, and exponential functions. This right here, it actually kind of applies for this right here, because we do see the inverse sine x. This works for a pretty good amount of time, I would say, most of the time, but not all the time. You will see for later on. But anyway, though, let's see. Differentiating inverse sine, we get 1 over square root of 1 minus x squared, which is really good. And now, ladies and gentlemen, when we integrate this, pick u to be the inside. The derivative of that is negative 2x. And the x will cancel out. And just work that out, you actually end up with negative square root of 1 minus x squared. Just go ahead and try this. When you differentiate this, you get negative 1 over square root of 1 minus x squared, and then multiply by negative 2x. Well, actually, you have a 2. The derivative square root is 1 over 2 square root, right? Negative, negative cancel, 2 and 2 cancel, so you get that back. That's all. All right, this is so much better. Why? First off, we know this is the first part of the answer, so I'll write this down right here. Let me put it down as negative square root of 1 minus x squared times inverse sine x. Right, so that's what we have. And then, of course, we are going to multiply by the second row, and this is still going to be an integral. Negative times negative becomes a plus, and then we have to integrate. Guess what? This and that cancel out very nicely. We just have to integrate 1. So multiply them, we have to integrate 1, and that's in the x world. So that's just pretty much x. Yeah, so finally, I'll just say this is negative square root of 1 minus x squared inverse sine x. And then we just have to add an x to it. And then guess what? We are done. So of course the plus c, just like that. All right, you know the deal. We are going to be doing integration by parts. So if you would like, of course, put the d and also the I. And imagine that if this is just an integral that you see on the street and you have to integrate that, how would you approach this, right? Because on the street, you wouldn't know you should just use integration by parts every single time. Well, I will just tell you, look at this, you should always try to do u sub, right? You should always try to do u sub because I think that's the fundamental integration technique. So if you do u sub in this case, it looks like we'll just make the inside to be the u, which is going to be like this. So let's do some scratch work, and you see the du is just going to be 1 over x dx, right? But you will see that this is actually not going to be helpful at all. Yes, you can isolate the ln x, and it looks like we have ln x being u minus 1 on the top, and then over this right here is the u, and then we will have to square that. So it seems like it's not so bad, right? However, dx is equal to what though? Well, look at this. I will have to tell you dx is equal to x times du. And because u plus 1 is equal to ln x, well, we know that ln x is equal to u minus 1. So do e to the power on both sides. The x right here is the same as saying e to the u minus 1. So in fact, I will have to multiply by e to the u minus 1 and then of course the du. And because of this guy right here, and yeah, I don't think this is we are not making much progress. You can try to do integration by parts right here and continue, but let me show you another approach. Notice if I wanted to do u sub, I will produce the 1 over x. We didn't have the 1 over x right here, right? If we don't have it, why don't we produce it? So right here, I really want to have an x on the bottom, because if that's the case, well, they will cancel each other out really nicely, right? But of course, I cannot just multiply the x on the bottom without multiplying the x on top. So let's go ahead and do that. All right? And now, I will actually just focus on integrating 1, right? 1 over x times 1 plus ln x, and then square. Why? Because this part right here, you can just do this u sub and it's going to work out very nicely. I don't want to have any functions on the top, right? Because what I can do is just differentiate the top. And again, hope for the best. So I will differentiate x ln x. Let's do u sub in our head. Let u equal to 1 plus ln x, du is equal to 1 over x, so that will cancel. So we'll just have to integrate 1 over u squared, which is going to give us negative, right? Negative 1 over u, and u is equal to that, so I'll just put down 1 plus ln x. So that's the integration for that. So I should have said this is the integration for that. And then I will differentiate this. Well, use the product rule in action. First function times the derivative second plus the second function times the derivative first. So here we get 1 plus ln x. And do we see it? Yes, we do, right? I'm just going to multiply this and that because that will give us the first part of the answer. Well, in that case, we get negative that, which is negative x ln x over 1 plus ln x. And then, of course, we are going to multiply by this row and putting inside our integration. Negative, negative is positive. Integral, guess what? This and that cancel each other out precisely. So just have to integrate 1, and this is in the x world. So of course, we just have to add x. So this right here becomes negative x ln x over 1 plus ln x, and then we just have to add x to it. I'm not done yet, because I want to combine the fractions for you guys. Multiply this by 1 plus ln x, and then, of course, the top as well. And you will see, on the bottom is just 1 plus ln x, and this is negative x ln x plus x ln x. So they cancel, and we just have an x on the top. Ladies and gentlemen, when you want to do the integration for that, the answer is just x over